Hello everyone, and welcome to this session on the Trimble MX50. This is an introduction to the Trimble MX50 for ESRI users. So Trimble has a portfolio of mobile mapping products, starting with our flagship, the MX9, which is designed for survey and engineering applications. And then we have our new product, the Trimble MX50, which has been launched recently for mapping and asset management applications, and the MX7, which is an image-based system with no point clouds for those that are interested in collecting imagery for photogrammetry and asset inspection. So this is our new product. The Trimble MX50 was launched on the 12th of July, and we're going to specifically focus on this product during this session. So just a little bit more about our portfolio. Trimble has a portfolio of mobile mapping products with a variety of applications and price points that we believe would be interesting for many different kinds of user. If you look at the application, as mentioned previously, MX9 for high-end surveying and engineering, the MX50 for asset management and mapping, and the MX7 for imaging for those people that want to collect a type of street view kind of workflow. If you look at the columns just in from the right hand side, indicates our software and workflow for each of these products, and an important point to make is that we have the same workflow across our portfolio. So no matter which product a customer selects, the workflow is the same. This is very important because it means that for example, somebody that has an MX9 and would like to now add an MX50 to their fleet, they don't need to change their workflow. It's exactly the same as it was with an MX9 or indeed an MX7. So a little bit more about the workflow. So we consider 4 steps in the whole field to finish workflow: capture, process, extract, and share. Capture, process, extract, and share. These are the 4 steps in our workflow, and just to indicate what that means in practical terms. So in the field, we have our TMI field capture software for all 3 products. Customer simply needs to connect to whichever system it is with the mobile device. Usually it's a tablet, and there's a very simple process for connecting with a web browser to the system and simply capturing the data required in the field. That data, once the mobile mapping mission is complete, is transferred to the office, and it goes primarily to begin with in Trimble Business Center or TBC. And in that software, people can do all the basic stuff they need to do with the raw data, so they can process the trajectory, generate point clouds, do things like registration, run to run, or registration to control points, point cloud colorization, image blurring, and then exporting the data, processed data. Then when the data requires extraction, there are actually 2 different workflows For customers primarily interested in survey and engineering deliverables, much of this can be done by continuing in TBC. TBC, the data can be integrated with data from other sensors and can be used for generating things like ground models, profiles, cross sections, all that kind of survey and engineering type deliverable. If the workflow is more asset management and GIS based, the user can take the data into our Trimble TMX software, and TMX has a very nice workflow for working with GIS kind of solution with features, attributes, creating topological data structures, or even importing schemas, etc., from existing geodatabases. And then finally, and a very important point in the process, sharing the data to get the most value out of the collected mobile mapping data. It makes a lot of sense to share the data widely across your organization to really leverage the true value of the data. And this can be done by publishing the data and sharing it simply in a web browser by sending people a URL. So non-expert users can access the data and really leverage the value of the data across your organization. So I come back to these 4 steps again: capture, process, extract, and share. Just have a look at that in a bit more detail with some examples. So this is our field software, which is normally running on a tablet device, simply in a web browser. So here we're in Google Chrome, connected to the device itself. Very simple user interface for operating the system. Can move between different windows to get a preview of images, point clouds, navigation data. So this is the point cloud option, where you can see the point cloud as it's being collected. And then when a customer is ready to start recording data, they can simply start that run by pressing the button in the bottom right, and it turns to red, which means you're in recording mode, and the data is recorded. When you want to stop a run, you simply press the red button in the bottom right corner. Process, so this is some data that has been processed and is in Trimble Business Center. So all the steps have been followed here to generate this point cloud. So trajectory has been processed, scans have been generated, runs have been registered to each other, the point cloud has been automatically classified, and the point cloud has been colorized using the imagery. Extracting the data, so this is an example of TMX. This is just one example of the kind of thing you can do in TMX. There are plenty of different data extraction options in TMX, from manual workflows to semi-automated workflows. The example I'm showing you here is a pole detector for automatically detecting poles. So in the top window, I'm creating an area of interest, and I want this automated routine to look for poles within that area. So you'll see in the top window, it starts to populate the poles that are detected, and this is automatic. Then if we review in the bottom window, do a kind of virtual drive-through of the environment, you'll see that the poles detected and displayed in the image view also. And then sharing the data, this is just an example of data that's been published on the internet and viewed in a web browser. And this can be shared with anybody that has access. Of course, there are controls within this product to control access. But if you send somebody a URL, they can access the data in a web browser and even do things, basic things like take measurements from the scene. So a little bit more about the MX50 product, which is new. So the MX50 is a practical mobile mapping system for asset management, mapping, and road maintenance. It builds on our experience in mobile mapping. One of the main features here is that for the first time in a mobile mapping system, we're using Trimble designed and manufactured lasers on this product. So there's no third-party lasers. These are Trimble lasers. There's a 360-degree camera and a Planix GNSS IMU unit, and we believe the system to be significantly more cost-effective to the end user. So here's the system overview, and these are the components of the system. So there's the sensor head itself, a roof rack, a control unit, and a power unit. There are two laser profilers arranged in a butterfly configuration, each measuring at 480 kilohertz and rotating each at 120 scans per second. We have a 360-degree spherical camera. We have GAMS, which is a secondary antenna for aiding the heading determination of the system. And yeah, there's a single cable connection from the vehicle to the sensor head. So this is what the system looks like in general terms, and these are the components. So there's a roof rack which is supplied with the system. Then there's the sensor head itself with its 360-degree camera, lasers, and IMU GNSS system. Secondary antenna for aiding with heading can be installed. There's an optional DMI, which is a distance measuring instrument that fits to the wheel of a vehicle. That's optional, but can be recommended in GNSS challenged environments, let's say. Inside the vehicle, we normally recommend installing a secondary battery to the main car power supply. And this is connected to our power unit, which connects to our control unit, and that connects to the sensor head itself. We create a Wi-Fi hotspot within the vehicle, and then the user connects with their own device, whether it's a tablet or a PC, to the system and operates the system from a web browser. Some of the specs of the system, there's quite a lot of information here, but I'm just going to highlight the main features. So we have 2 laser scanners and a Ladybug camera. We have the Planix AP20. The weight of the system is 23 kilograms, which is significantly lighter than some of the previous systems. The effective measurement rate is 2 times 480 kilohertz with a scan speed of 120 scans per second. What does this mean? Effectively, this means that we're collecting approximately 1 million points per second. The maximum range of the system in terms of the lasers is 80 meters. A little bit of a look at some of the data that we have been able to collect using the MX50. So we have this well-defined data corridor. So I mentioned that the range is 80 meters. So this means that we're getting approximately 160 meter wide corridor, 80 meters either side of the vehicle's trajectory. This is a hard cutoff at 80 meters. It's not like a potential maximum range. It's actually a hard cutoff at 80 meters. And it means that we get a very clean data corridor. So we don't have all long distance points, which could be less accurate because they're very much dependent on the accuracy of the heading determination. So we really focused on a concentrated area of interest of this 160 meter data corridor. And to some extent, this is kind of a nice feature, almost an advantage. Here's a look at some of the data. Here's a highway, a colorized point cloud of a dual carriageway. This is a street scene in Germany. This is the point cloud, colorized point cloud, not an image. You see how high quality and good the data is in general, with very little noise. Demonstration here of the kind of accuracy of the data. So at the top here, running from the right to the left, is are 4 runs, actually, 4 independent runs along the road. So all the point clouds are on top of each other for the 4 runs. And then I've put a cutting plane through that, as indicated by the yellow rectangle in the top. And I'm going to zoom in here on these 4 point clouds from these 4 runs on the road surface. So the colors here represent different point clouds from the different runs. As you can see, they're all mixed up. It's all fairly random. And by measuring kind of the depth, if you like, of this road surface, basically it's giving me an indication of the consistency in the vertical between these 4 runs. So if I measure that, you'll see that it's about 9 millimeters. So we're getting about 9 millimeter in the extreme, by the way, repeatability between these 4 point clouds. That's why we believe this this product will be interesting for people that are interested in measuring road surfaces, because we're getting very good data on road surface. So the data from an MX50 is clear, it's precise, it can be used for survey, and it can be used for GIS. Here's another demonstration of the fidelity of the data. So we put some objects in the road. piece of cardboard, some pieces of foam, a carpet tile, and concrete slab, and drove over them with the MX50, and this is the resulting point cloud. You can see the objects appear very clearly, and we were even able to measure the depth of the carpet tile. MX50 data, a small project we did close to our office in Germany. It's a road intersection, quite a complicated one. There's a roundabout with several different entrance roads and actually a flyover. The cyan colored trajectory across the center is actually a flyover. So reasonably complex road junction, and I'd like to share some of the data we got from this project with you. So this is kind of the size of the project. It's approximately 1,300 meters by about 570 meters. There are 11 runs. There's a flyover, and the total distance was 5.7 kilometers. So if you were to add all the runs together, it's about 5.7 kilometers. The time it took to do this survey was 50 minutes. So very fast way of doing a survey, that's for sure. In fact, I just want to share with you something from my own experience. I did a similar way back in my young surveyor days. Total stations had been invented in 1987, and we were using a total station. But it's a similarly complex road intersection in West London that we undertook with a total station. And this project, due to its complexity, the busyness of traffic, etc., this project took us 2 months. So in the course of my career, we've gone from 2 months to 50 minutes. So we registered the runs together in this project and classified the point cloud into buildings, ground, high vegetation, post signs, and power lines. This is a feature in Trimble Business Center where the point cloud can be automatically classified into these 5 regions. And then the data was exported to TMX. So let's have a look at the data. So this is the colorized point cloud. You see the vegetation and the ground surface very clearly indicated. Being able to switch off different components of the point cloud to get to the ground, so just to have the ground switched on, is very, very useful for example, creating a DTM of the ground surface. To be able to filter the data in that way is very useful. Here's a view of the resulting colorized point cloud. Another view, you see the flyover going across the center of the project. This is a view on the roundabout section of the project, where the vehicle's probably traveling about 40 kilometers an hour going around this section, and this just helps you to understand what the data looks like. You'll see the grid pattern created by the 2 lasers in the butterfly configuration gives us around about an 8 centimeter grid pattern on the road surface itself. You'll also notice the data on the road surface is very clean and there's very little noise. Again, just another example of a road sign that's I'm just looking at independently here. There are 3 runs here, so again we'd expect to see some misalignment between the three runs, maybe some noise around this point cloud from the different runs that have points on this road sign. But if you look at the image on the right hand side, just looking side on, you'll see you could measure the thickness of the road sign, and there's very little noise, very good agreement between the three runs or the 3 point clouds. Just want to say a little bit about Trimble MX Publisher and some of the plugins that are available. We have several plugins. I want to focus on the ESRI plugins here. So different projects are basically created and become publications, and these can be published over the internet and shared in a web browser. And we have a plugin for ArcGIS or ArcMap, and I want to just share with you some of the features of that. So here we have on the right window, we have ArcMap, and I'm connecting our plugin to our publisher platform with a project. So now we have a connection between ArcMap, the ESRI world, and the TMX publisher, the Trimble world on the right. And now I'm going to extract some points. You'll see the vehicle trajectory is displayed on the in ArcMap, and I'm extracting now some road sign on the right hand side from the publisher platform, and you see that is been extracted, created, and saved interactively to ArcMap Online. Just moving along to another road sign, extract it in Trimble MX Publisher. It appears in ArcMap on the left-hand side, and I can save it to the ArcMap database. Now I'm going to do something similar, but this time extracting a line feature. So it's actually the road marking, the line across the left-hand side of this lane. So you see this has been extracted in the point cloud in MX Publisher, but you'll see the line is appearing in ArcMap and is extracted to a layer in ArcMap and can be saved to the ArcMap database. So there's this constant real-time connection between TMX Publisher and ArcMap Online. We can also just show you some of the features available in Publisher. We can add annotations. So here we're just adding an annotation to say, here's a bridge, appears in the point cloud and in the image. And then I just want to show you some measurement tools as well. So if I pick up the measurement tools, just show you one for doing offset measurements. So here, measuring a kind of right angle triangle with slope distance, horizontal and vertical offsets to that point on the bridge. And then finally, measuring an offset, measuring this lane width here, simply by measuring an offset. So I hope that gives you an idea of how mobile mapping data using TMX Publisher can be used very smoothly in the ESRI world. Thank you. That concludes this presentation. Thanks for watching.